All right, today we're in section 12.2, angles of triangles. All right, and what do we just say is the sum of the angle measures of a triangle? 180. So that's what we see down here in the algebraic formula, x plus y plus z. What does that mean? It basically means the three interior angle measurements, x, y, z, would represent those three angles, will always equal 180 degrees. Now we're going to spend example 1 talking about interior angles, and then we're going to spend example 2 talking about exterior angles. Okay, and we can calculate them a little bit differently. All right, but for now we're going to focus on interior. Y'all ready? So looking at example 1, okay, we're going to use this knowledge to solve for an unknown interior angle measure. All right, so we don't know the measure, let's start with the red triangle, of angle X, but we can put that into an equation to solve for X. So we could say X plus 32 plus 48, and what do all those angles have to add up to be? 180. So if I know that, then I can solve for X. Now we want to look for like terms that can be combined on one side of the equation. Do you guys see anything that can be combined there?
32 and 48.
Yeah, 32 plus 48 is? What's 32 plus 48? 80. Now if you want to go ahead and add that, and as your original problem you say plus 80, that would be fine. But you must write an equation. It's very important that we learn how to write equations, and this chapter really gives us a lot of practice there. But if you're just solving it in your own mental math way, okay, you're missing a lot of what this chapter is trying to teach you. Okay, so x plus 80 equals 180. Now what do I do to both sides to solve for x? Subtract. X equals 100. Okay, now this technically is not my final answer. Yes, I need to solve for the unknown angle measurement, but it says find the measures of the interior angles. So what we're going to do as our final answer, and this is what we'll be checking on tomorrow's homework, is I want you to list out each angle measurement. In this case, it would be 32, 48, don't forget your degree signs, and 100 degrees. So now you're going to go back and list, these are my three angle measurements of the triangle. And just like we talked about at the beginning of the lesson, okay, at the very beginning, there are so many combinations of angle measures that could be 180. All right, you're probably not going to see that combination again. Okay, there's just a lot of different combinations. All right, let's look at this next problem. This one looks a little different, doesn't it?
Yes.
A little bit. But the process is still the same. Anybody tell me what this red box means? So that's going to be a 90. Okay. Plus x plus 28. Now, I need to talk about these parentheses. Technically, because it's addition, those parentheses really don't have any bearing at all. I could have them or not have them. The reason I have them is to show this is one angle measurement, but it does not have any impact on what I need to do here. And what I need to do here is I need to combine my like terms together. Okay? So do you see the x plus x? What's x plus x? 2x. And then the 90 plus 28, what's 90 plus 28?
118.
118. Okay, do you see how I did that? So the parentheses have no effect on actually what we're doing as far as combining like terms, because it's addition. If you remember back to the chapter where we had to subtract and then do the opposite sign of everything inside the parentheses, but you're not subtracting. You always add the angle measurements together. All right, what's my next step, guys? What do I do next to solve for x here? I need to subtract what?
118.
118 from both sides. So minus 118, I get 62. All right, last step, Addie, what do you think? 2x equals 62. Yep, divide both sides by 2. And x equals 31 degrees. But that is not my answer. Remember what we did once we solved for x on the last problem.
Yeah.
We now have to go back and say, these are the angle measurements of this triangle. So what did that red box mean?
90.
90. Okay. And then I also found, I didn't mean to hit that button. I also found 31. But then I have to figure out x plus 28. So what I do now is I take this 31 and I plug it in for x. So what's 31 plus 28? 59. So it's going to be 59, 90, and 31. In no particular order. If you write them in a different order, that's fine. But does everybody see how I got 59 degrees?
Yeah.
And why it's important that I'm actually going to list them out? Because sometimes I have to do more math. All right, sure, 31 equaled this x, and that was it. But on the other one, I had to do some math. All right, how do we do, guys?
Good.
Do okay? All right, I want you to work together in your groups on the think, pair, share problems. All right, this is a real important concept in the lesson, so I just want to take a time out here just for a minute for you guys to kind of work together. I'm going to walk around, check on you, see how you're doing, and we'll go from there. All right, so we have x plus 81 plus 25 equals 180. Did you guys write your equation?
Yeah.
X plus 106 equals 180. When I add my like terms together, subtract 106 from both sides, and we have 74. Remember, we need to go back and list them. All right, 25, 74, and 81. All right, now this one is, kind of straightforward as far as I didn't really have to do anything after I solved for x because the other numbers were just there. It's a different story for the second one. All right, so on the second one, we have x plus x minus 35 plus 43 equals 180. Okay, so again, this x minus 35, it could be in parentheses or not in parentheses. That doesn't change how we're going to combine our like terms. What's x plus x?
2x.
2x. What's negative 35 plus 43? 8. Now, if you had it the other way around, it's no big deal. It's still going to be 8. Okay. Maddie, what's my next step?
Subtract 8 from 8 and then
Yep. Colin, what do I do last?
You divide 172 by 2.
Yep. And what do you get?
Wait. 86.
Yep, 86 degrees. All right, very good. So now, but that's not my final answer. Now I've got 86, 43, but how do I find that third angle measurement? Anybody know? Yes, you take the 86 and you minus 35. Okay, you get 51. All right, who got that right? Or both of them right? Okay, good job, guys. Now, exterior angles, I'm going to go by a different set of rules, okay? So, exterior angles, here's what my rule says. That the exterior angle is equal to the sum of the two non-adjacent interior angles. Non-adjacent means they're not touching that angle, okay? Adjacent, remember, means that it shares a common side and a common point. So this is the adjacent angle. So my rule says that it's the two non-adjacent angles when I add them together. It's going to be the same exact measure. All right, so here's what I'm going to do to solve these. Again, I'm just going to go by that rule that x is going to equal the sum of the two non-adjacent interior angles. Sorry, I just lost my connection real quick. Just lost my internet. Should be back in a second. Or two. Oh, come on. No, internet, where did you go? All right, so here we go. It's back. It's still slow. All right, long, awkward pause, and here we go. All right, so we have x equals 36 plus 72. I just wrote it the other way, but it's the same thing, okay? That this exterior angle will equal the sum of the two non-adjacent interior angles. So what's 36 plus 72?
108.
108 equals x. That's it. Okay? But now I get over here to this next one, and it's like, okay, this one's a little different. But the concept is still the same. That my exterior angle equals the sum of the two non-adjacent interior angles. Okay, so here's my exterior, 2a, equals the sum of 80 and a minus 5. Are there any like terms on the right side that I can simplify?
85.
Okay, what's 80 minus 5? Okay, so 2a equals 75 plus a. So we have something that you haven't seen quite yet, okay? We haven't done a whole lot of equations where you have a variable on both sides, okay? So it's going to start popping up more and more, and here's your rule. You don't want a negative number connected to your variable, meaning if I try, and I have to have my variables on the same side, so if I try to subtract 2a, don't do this, just look up here. What's a minus 2a? Negative 1a, and everything is now on this side of the equation, which does me no good either. So instead of doing that, here's my rule of thumb. I want to choose the lesser of the two variable values. So is a lesser or 2a? A is less. So to move it to the other side, I do the opposite operation. Does everybody see that a is positive? So I will minus a to the other side. That cancels it out and gets my a's on one side of the equation. And what's 2a minus a? Just a. Equals 75. Okay, so when variables are on both sides, I want to move the smaller one. How do I move it? Whatever operation is opposite. It was plus a, so I can minus a to move it to the other side. Here's my problem though. It said find the measure of the exterior angle. My exterior angle is 2a. This is 1a. So double it. All right. What's 2 times 75? What's 2 times 75? 150. So 150 is the measure of the exterior angle. Okay, almost done. Yes, this is the Bermuda Triangle. Yes. Okay, we know there's a lot of theories, right? Conspiracy theories. We are not here to discuss the Bermuda Triangle. Okay, so yes, it's the Bermuda Triangle. All right, but more importantly, okay, why does it form a triangle? It's because of a flight route. Okay, so an airplane leaves Miami and travels around the Bermuda Triangle as shown in the diagram. So look at what it's asking you specifically. What is the measure of the interior angle at Miami? So from Miami to Puerto Rico, up to Bermuda, and back. All right? Well, each turn forms an angle measure. So we see x plus 62.8 plus 2x minus 44.8. So guess what we're going to do with all those angle measurements? We're going to put them into an equation. And we're going to solve for x. Okay? So I just added up each angle measurement. Okay? And I know that it's going to equal 180. All right? You guys know that planes fly in routes, right?
Yes.
Obviously, that's how we keep them from colliding mid-air with other airplanes. So those routes, they form angles, all right? Whenever they make a turn, you know those turns that it makes, and sometimes you're like in the side window and all of a sudden you're looking at the ground because it's turning. Yeah, I know, it's a little freaky. Okay, so anyway, all right, let's go ahead and solve for x. Okay, so x plus 2x. Did y'all get 3x?
Yes.
Okay, 62.8 minus 44.8. What'd you get? 18 equals 180. Now, what do I do next?
Subtract 18.
Yeah, subtract 18 and divide by 3. And x equals 54 degrees. But I'm not sure, is that what it was asking me to answer?
Yes.
Okay. X is 54 and it wants me to know Miami. And Miami is only X. Now, if it had asked me for Puerto Rico, would I be done?
No.
No, because I'd have to multiply by 2 and subtract. But because it asked me for Miami, I'm done. Okay? So you don't have to go back and say all 3 because it only asked for Miami. All right, that's going to be everything you need to know for triangles.